Hello everyone, welcome to Math 215, which is complex variables and Laplace transforms. This is going to be lecture 1 of an ongoing online lecture series in the BUX platform. I would like to start off this lecture with a relatively soft introduction to what is known as imaginary numbers. Since up until this time, we've predominantly worked with real numbers in Math 110 or Math 120. Let's say you have an equation which is x squared is equals to minus 1. Now you want to evaluate what x is. So you take a square root on both sides, and you get x is equals to root over minus 1. Here lies the issue. Because there is no square root of a negative number. Now, what mathematicians have devised is make this square root of minus 1 into what is known as imaginary numbers. Here, what was real number has turned into what we now call an imaginary number because there is no real number counterpart to square root of minus 1. Here I wrote I, so as you can see, I is equals to square root of minus 1. So formally, the definition, or the identity, so to speak, of I square is equals to minus 1. This is an important fact that you have to carry on throughout the whole semester, throughout the whole course. Now, we know already that real numbers come in the form 1, 2, 3, 4, pi, e, etc. An intuitive way of understanding what real numbers are in general is you can think of as, say, take for example the number 2. You can think of 2 as a multiple of 1, or pi as a multiple of 1. See, you're getting 2 when you get 2 is 2 times 1. In the same scenario, say for example you want to write an imaginary number. An imaginary number, say I, 2i, 3i. Intuitively, or say pi I, because I wanna stress the fact that imaginary numbers also contain irrational numbers. So imaginary numbers you can think of I in the imaginary sense as the multiplicative counterpart of the real number, 1. So an imaginary number, say for example twice I, is simply 2 multiplied by I. A multiplicative coefficient of I. Or even, I can extend this definition to even irrational numbers such as pi, which is pi times I. Now that we know what an imaginary number is, let's figure out what complex numbers are. And I'll start this by introducing, again, giving another soft introduction to what real numbers are. You can think of real numbers as a straight number line. Say, you take this straight number line, in between you have 0, and this we call the real number line. Here you have all the numbers which could ever exist in the real number domain, which is 1, 2, 3, there's pi here in 4, so on and so forth, and including negative numbers as well, minus 1, minus 2, minus 3, and so on and so forth. So, what are complex numbers? If we stick to the definition of graphically explaining explaining the number system, we can extend this definition to the complex number system as well. Here, for the real number system, it's a one-dimensional line. But for the complex number system, we make it a two-dimensional plane. Here is this real counterpart here, and there's also an imaginary counterpart. Since complex number systems are an amalgamation of real numbers and imaginary numbers. So here you must include a real number part and an imaginary number part. The real number part goes as follows. 1, 2, 3. There's also pi here, which is 3.1415, and it goes on, it's an irrational number. 4, and so on and so forth. And here we have the the negative numbers. And I explained that this complex number system is what we call a complex number plane. So orthonormal to this real number line, or perpendicular to this real number line, we have the imaginary number line, where all the imaginary numbers reside. Here you have I, 2i, 3i. And here you have the negative imaginary numbers, -i, -2i, so on and so forth. And again, since we're going on tradition here, I'm including pi here, so let's include a pi I counterpart. Here you have pi I. So now you have a visual representation of what the complex plane looks like. It is tradition to write the variable, to write a complex number, denote the complex number, as z. So you will see this letter a lot in this course. So we say z consists of this real part, which is x, plus this imaginary part, which is y. Let me label them. This is what is called the real part, and this is what is called the imaginary part. It's also worth to note that if somebody asks you, what is the real of z? You include the real number part, which is x, whatever form it takes, x. They could also ask you, what is the imaginary part of z? Which here is y, the coefficient of y, or the multiplicative number of the imaginary number, which is y. It's also worth knowing that x, both x and y, are real numbers. What makes this whole part an imaginary number is the fact that you're multiplying I to it. Now let's see let's give you an example of what a normal complex number looks like. Let's say you have z is equals to 2 plus 3i. Now, if say for example, I gave you a normal real number and I hide this part, I'm hiding this part, you have just a real number, which means your imaginary part is 0. And what this real number would be on the real number system? It would be here, exactly this point, as in real numbers are just points of the real number line. Now, the complex counterpart to this graphical representation would be, look at where 2 is in the real number line. Okay, so 2 is here. Look at where 3i is in the imaginary number line, which is here. And where do they both meet? Here. Just like any two-dimensional xy graph, the same thing happens here, where you have one real number, and one imaginary number. So there you go. There is your complex number. Thank you.